Hello Code Crew, welcome to the Core Data series. In this lesson, we're going to go through what core data is, its benefits, and how you're going to use it with Xcode. First of all, what is it? Core data is Apple's local object graph persistence framework. Now, before I scare you away, in simple terms, it's a way for you to store data on your device locally and then retrieve it later for use. The data stays locally on the device, so it's not a solution for sharing data with other users, and it's not a solution for syncing data across multiple devices, although some of that can be done when you combine core data with CloudKit. Next, why should we even use core data? Well, assuming you need to store data in your app, some benefits of using core data include, number one, it's a first-party Apple framework, so it plays nicely and has a tighter integration with other Apple APIs and frameworks. Number two, being a first-party framework means that Apple is going to make sure that any new technology it releases will work with it. At least I'd like to think that Apple would make a bigger effort to make sure that core data plays nicely with anything that they release. Number three, you don't have to install any third-party SDKs, which means you don't have to work with CocoaPods or trying to keep third-party code libraries up to date. Alright, now for some drawbacks of using core data. Number one, it's not a remote database solution, although syncing across devices should be able to be done with CloudKit. To be honest, I haven't looked into this very much myself yet. Number two, the classes and methods to work with core data may be confusing at first, so there's a little bit of a learning curve, but I hope in this video series I can simplify that for you. Number three, you have to retrain your brain to think of core data as an object graph persistence framework. Object graph persistence framework. Let's take a look at what that means. It all has to do with how you interact with core data. You see, with traditional databases, you explicitly insert, create, update, and delete data from the database. Now, even though under the hood, core data is using an SQLite database, you don't have to explicitly tell core data to insert, create, update, or delete. You just create and work with objects in your app like normal, and behind the scenes, core data will manage the data persistence for you. Let's take a look at a diagram to see how this works. Okay, so let's say you have two classes, family and person. The person class contains some properties, and the family class has a property storing the person objects for that family. You create a family object and several person objects, and then you relate those person objects to the family object. Now you want to store it in core data. How do you do that? Well, there are a few core data components that are needed. One is the persistent container. You can think of this as a representation of the core data store or database. However, your objects don't interact with the persistent container directly. There's a layer on top of the persistent container called the managed object context. Think of this as sort of a data manager layer. Your objects will go through the managed object context to be stored or retrieved from the persistent store. Now, these objects in memory, along with how they relate to each other, is called an object graph. When you store the objects into core data, all of the data in the properties along with the relationships are preserved. In other words, the object graph. When you retrieve them from core data back into memory, you can get them back in the same state they were in before. So that's why they call core data an object graph persistence framework. Now, to complete our understanding of how core data works, let's revisit our diagram. In previous lessons, I've shown you how to work with JSON and decode them into usable objects in our app. This process of changing the data into a different format and back is known as encoding and decoding, or serializing and deserializing. Well, core data needs to do the same thing here. It serializes the object into a format that can be stored in the underlying SQLite database, and then it'll deserialize it back into the objects in memory. The code or functionality to do that serializing and deserializing process is with a class called NSManagedObject. So if you want your class to be able to be captured in core data, you need to subclass NSManagedObject. That gives objects of your custom class the ability to be stored with core data. Okay, so now your objects can be serialized and stored with core data. However, when you want to bring that object back from core data, how does it know what format to deserialize that data back into? In other words, if you're trying to bring your person back, how does it know about your person class and what properties your person class contains? Well, here's the final piece of the core data puzzle. In this example, we use the person class that subclasses NSManagedObject. Well, you don't actually create and write this person class yourself. Instead, there's a visual editor where you have to define the class in the core data model. They call the class an entity, and the properties of your class are called attributes of that entity. Then, after you've defined the entity and attributes, in other words, your class and its properties, you generate the Swift classes from this core data model file. It's just a command you run from an Xcode menu, and it'll generate the class files for what you've defined in the core data model. The generated class will automatically be a subclass of NSManagedObject so that core data can serialize and deserialize it. Then you use that generated class like you would any other class, and core data can now store objects of that class and bring them back when needed. So let's do a quick recap of how we're going to work with core data. You define your entities and attributes in the core data model. Then you generate your classes from the core data model. Then you get a reference to the core data persistent container. From the persistent container, you get a managed object context. And through that managed object context, you can create objects and store them in core data for retrieval for later use. Now, core data has a stigma of being hard to understand and use. I hope I've demystified it at least a little bit for you in this video. In the next lesson, we'll do a real example of using core data in Xcode. All right, I'll see you there. Hey Code Crew, in this lesson, we're going to do a real example of using core data inside Xcode. I'll go through two different scenarios. Number one, how to start your Xcode project with core data enabled. And number two, how to add core data functionality to an existing Xcode project. Now, even if you're only interested in number two, I would still highly recommend that you watch through part one, because in part one, I'm going to be highlighting the different core data components that are needed. Now, just a quick recap of the previous lesson in case you didn't see it. To work with core data, we need four things. Number one is to define our entities and attributes in the core data model. Number two is to generate the classes from the core data model. Number three, get a reference to the core data persistent container. And then number four, get the managed object context through which we save and retrieve our objects. All right, let's jump into Xcode and do this. All right, first we're going to talk about setting up core data with a brand new Xcode project, and then afterwards we're going to talk about how to add core data to an existing Xcode project. So here I'm going to set up a brand new Xcode project here, and I'm going to choose single view application, and all you need to do to set up core data is to make sure this checkbox is enabled. So let's call this our core data demo, and just make sure that's enabled. And let's hit next. Oh, by the way, I am still using Storyboard's UI kit here. So if you're following this demo, you can select the same thing. Let's click next, and I'm going to save this on my desktop. Now, the first thing you'll notice is that enabling that use core data option gave you this file along with your new project, this XC data model file. And when you click that, you get this visual editor to define your entities and attributes. If you remember from the slide we just saw, the first step is to define our entities and attributes. So let's go ahead and do that through this visual interface. Down here, click Add Entity, and you're going to see your new entity here. Now you can either edit the name by clicking it once, so you make it editable, or you can come in here and just change the name of the entity. So I'm going to use the same example as we did in lesson 1 of this core data series, which is to use the person and family analogy. We're only going to start with person for now. Later, when we talk about relationships in core data, then we're going to define our family entity as well. All right, so before we move on to attributes, there are a couple of things I want to point out in terms of the attributes for the entity. Number one is the name, which we've just defined. Number two is this module or namespace. If you have an Xcode project which houses multiple modules or Xcode or other projects, then you can define which namespace you want this entity to be a part of. By default, it's global. So I think for most of us who are just creating an Xcode project for a single app that has one module, you don't have to worry about this. But just in case your project has multiple modules and you don't want this person class name to clash with some other person class name in another module, then you can definitely define the namespace here, or rather which namespace this person is part of. The next part is code gen. Now, after we define our entities and attributes, when we generate the classes, you can actually do that either manually or have Xcode do that for you when you build and run the app. By default, Xcode will do it for you automatically. But for now, I want you to change this option to manual none, because I want to show you how to do it manually. And then I will also tell you about the other two options, because there are trade-offs to be made. So let's go ahead and select manual none for now. All right, now we're ready to add our attributes. So under here, you can click this plus symbol to add a new attribute, or you can click this add attribute icon down here, which I think is not as intuitive as this guy. So go ahead and click add item, and then you can give it a name. So our first one was just name. So let's just name it that. And then the type, let's choose string. So we're going to add another one. We had gender here, and again, this was a string. Now the next one was age, and the type was actually an int. Now, you'll see in the type here, there's integer 16, 32, and 64. If you're not familiar with what those are, basically they define the size of the integer. Now I'm going to pull up a web page here that shows you the differences with the different integer types. So you'll notice that there's different types of ints. There's 8, 32, 64, and you can see that the ranges go up as this number goes up. And there's also a uint version of each of these sizes. U stands for unsigned, which means that there's no negative range. So as you can see, int64 gives you the largest range, but we don't usually have to select which type of int we use, right? When you define in Swift a new variable of the int type, you don't have to specify any of these. Well, under the hood, that int type that you specified is one of these types, and it really depends on what platform your code is running on, because different CPU architectures store data differently. Some are 32-bit, some are 64-bit, and some, as you can see, might be 8 or 16. There's this website here that I found specifying the different architectures of the iOS platforms, and you can see in here sort of what CPU architecture it's using and whether it's 32-bit or not. And as you can see, as we scroll down this list, these are the older iPhones and iPods and iPads, and as you scroll down to the newer ones, at this point, you know, in 2015, it looks like everything starts to be 64-bit. So as you can see here, down to, you know, the latest ones down here, it's all 64-bit. So it's safe to say when you're declaring a Swift int and your app is going to be running on one of the newer devices, 2015 and above, that it's going to be 64-bit architecture. So your int is actually an int 64 with this range. So going back to the core data now, what should you specify here? Well, don't get the wrong idea. Just because for the age you won't need such a big range, thinking specifying int16 might save you some memory or save you some space, it doesn't work like that. The memory allocated for that age variable will still be 64-bit. So you might as well just choose 64-bit. So that's kind of a long explanation about those, about what those differences are. Now you might also notice on this list that we don't have array types or you know, object types or anything like that. Well, if you wanted to specify, let's say, an array of, let's say for name, for example, and we wanted to specify an array of names instead, you choose transformable. And then over here on the right hand side, for the name attribute, you can set a custom class. And we can set this to be a type of string array. Or if it's maybe referencing another custom class that you have, you can put the class name there. And when this entity gets generated, this name attribute will be transformed into a name property of that type. So I'm just going to set it back to string for now. So if you want to learn more about configuring entities, there is Apple documentation for that, talking about the different attributes and the different things you can specify. I'll link this page in the description below the video. Now I want to talk about generating code from this entity, generating the classes, I mean. Now earlier I mentioned that there are a couple ways to do it: manual, class definition, and category extension. Let's start by manually generating this. So go ahead to editor, click create NS managed object subclass, make sure that there's a check mark beside your data model and a check mark beside your entity, click next, and you can just save it anywhere. It's going to create two files here, and typically what I'll do is create a model group and move that in there so things are a little more organized. So you'll notice that there are two files for your one entity, and it's person plus core data class and person plus core data properties. Let's start with this one. Now this one is the class declaration for person or your entity, and it's subclassing NS managed object, which I told you before that your entity or your class needs to do in order to be saved and retrieved and basically work with core data. Now this second file is an extension of your class. So if that's new to you, just think of these two files combined together is your complete person class. This extension contains all of your attributes as properties, and you can see the data types are exactly what we specified. Notice that there's also this type method here called FetchRequest. So later on, we're going to be able to generate a query or a fetch request simply by typing person, the class name, .fetchRequest, but we'll get into that part later. For now, the key thing I want to mention is why this is split into two classes. The reason is because for this class definition or declaration here, this is where you want to put all of your custom code. If there are custom methods you want to put into this class, this is where you would do it. This one, I would try not to modify, because when you regenerate these classes, maybe you've made a change to your model and you regenerate these classes, whatever changes you've done here are going to be overwritten. So speaking of which, whenever you make a change to any of the attribute names or the types, or maybe you add a new attribute or something like that, you're going to want to regenerate those classes. So then you can go ahead and delete your classes. If you've made changes here, definitely don't delete this file, only delete this one right here, right? Because this is the one that just defines all of your properties. But this is what manually generating your classes entails. You're going to have to manually make sure that this extension, this property extension here, is up to date with what you've defined here. Now let's talk about having Xcode automatically generate these classes for you. So if we click on the entity and we go under code gen, by default, if you remember earlier, by default it was set to class definition. When it's set to this, you don't have to manually generate the classes. So you wouldn't have these. You would basically delete these. You wouldn't have done this. What happens instead is that when you build your Xcode project, those two files right there, they automatically get generated for you behind the scenes. You'll never see them. That means you cannot edit them. So a drawback with having Xcode automatically do this for you is that if you wanted to put some like custom logic or custom methods in your person class, you can't, because you won't have these two files to modify. But the advantage is that you don't have to manually make sure that this file is up to date with whatever you've defined here, because every time you build your Xcode project, those two classes will get regenerated behind the scenes. So what we've done here is we've manually generated these, and I have the entity set to automatically generate it on build. What's going to happen if I build the project now? Well, I'm going to get an error, because what's happening is when I hit build on Xcode, it's trying to generate those two files for the entity because I've set it to that, but it also recognizes that I have these two files here in my project, so it's clashing. If you look at the error, it's going to say, multiple commands produce that file. So this is what you don't want. In order to fix a problem like this, you can simply go ahead and delete these, move these to the trash. If you want to ultimately have Xcode automatically generate them for you, you move these two files to trash, go to product and then clean build folder to make sure you remove any artifacts, and then you can rebuild your project. Or if you want to manually do it, just set this to manual none. But you cannot have a combination of having Xcode automatically generate it for you and have these existing in your Xcode project. All right, so now for the last code gen option, which is category extension. When you have it set to this, Xcode is only going to generate this extension file for you automatically, which means you can go ahead and delete this. Now this is sort of like a happy medium. You can just straight up move it to the trash. This is a happy medium because you still get this one file, which you have to manually generate initially, and then you go ahead and delete that category extension file. But now you can add your custom logic and your custom methods, and you don't have to make sure that the extension containing all of the properties is up to date with the model, because having it set to category extension for the code gen, every time you build your Xcode project, it's going to generate that half of the class for you. And right now I have an error, probably because I didn't build my clean my build folder. As you can see, it's still complaining multiple commands produce. So I'm gonna go back to product, clean build folder, and I know that having this code gen set to category extension and having this other half here, if I press Command B, I'm gonna get the full definition of my entity. So I guess to sum it up, manual is full control, right? You have to generate two files, but you have to just make sure that it's like congruent with what you've defined here. Class definition is no control. You don't get to add, you don't get to modify the classes at all. It gets generated behind the scenes when you build the Xcode project. And category extension is it automatically generates half of it for you, and the other half you can customize the code. Okay, so now we've defined our entities and attributes. We've generated the classes. Now we need a reference to the core data persistent store. Well, when you created this Xcode project and you enabled use core data, in the app delegate, it's actually set up something additional for you down here. You can see that now we have this persistent container property. And this lazy keyword just means that it's not going to run all this code and create that container until you access it for the first time. But this is your core data persistent container, and it's a property in your app delegate. So that's how you're going to access this persistent container. As you can see here, this name here maps to this core data, this data model file right here. All right, so because this property is in the app delegate, we can access it from any view controller or any other class in our entire project. All right, now let's go into the view controller and let me show you how to access the persistent container from there. So we need a reference to the persistent container. You can access the app delegate first by typing UI application. I don't know about this one, but this is how I would normally do it. UI application.shared.delegate. And you can see that it's optional here, but the type is UI application delegate, but we got to cast it as our app delegate. Right? And then now that it's our app delegate, you can access the persistent container property. Right? So this gives us access to that core data persistent container. But if you remember from lesson 1, we don't interact with the core data persistent container directly. We use the managed object context. And in order to get a reference to that so that we can use the managed object context, we just have to access a property on the persistent container called a view context. You can see the data type for this is NS managed object context. So this is actually what we need in order to store our data, retrieve our data from core data, and all of that. But don't worry, I'm getting a little ahead of myself, because in the next lesson, we're going to look at creating, retrieving, updating, and deleting data through the managed object context. For now, I just wanted to show you how we can access the persistent container and also the managed object context. Now, before we go into adding core data to an existing project, I just want to show you one more thing in app_delegate, because aside from this persistent container property, there was also another thing down here called, it also added this save context method. And as you can see, all this method is helping you do is it's getting a reference to the managed object context and then detecting if there has been any changes to the data and then saving, right? So it's just an easy way for you to save changes to your persistent container. So you can do it by simply calling the save context method of the app_delegate. Okay, so when you start a new Xcode project and you enable core data right off the bat, you get the core data model file included, and in the app_delegate, you have methods to access the core data persistent container and managed object context. Now, if you have an existing Xcode project that you want to convert to using core data, you won't have these things currently in your Xcode project. Now let me show you how to add them so that you can use core data. All right, so now let's say you have an existing project that you didn't set up with core data. So I'm just gonna create a test project here, and I'm not gonna enable use core data. Let's create that there. And so let's say this is your existing project. Well, all you have to do, number one, is add that data model file. So go ahead and add a new file. And under core data, choose data model, right? And you can save this with whatever your name of your project is. So I guess I'll call this test project.xc data model. And here, you have your entities. You're going to define your entities and attributes as normal. Also, in app_delegate, you'll notice that you do not have that persistent container property that I showed you, and we don't have that save context method as well. So you would just essentially add that code here, but I don't really know that code by heart, and I don't expect many people will. So what I usually do is I create a brand new Xcode project with core data enabled just to get that code, and I'll copy and paste it in here. So I can take that demo that we were just working on, and I can copy this, right? That's the persistent container property, but you have to make sure that this name right here matches that, right? So test project, and that's the core data data model file that you added. And you also have to import core data at the top, because otherwise the classes wouldn't be recognized, right? And then you can go back to your other project and just copy the saved context code over as well. And it's as simple as that. Now the other thing is, in an existing project, you probably have your own model files already, or your own model classes, I mean. You would have to redefine them as entities here, along with their attributes and all of the relationships, which a couple lessons later we'll talk about. But you'd have to redefine all of those things and then regenerate the classes to replace your current model classes. And then you would also have to alter the way that you get the data. And in the next lesson, you'll learn how to create, retrieve, update, and delete data from core data. So you're going to have to modify your existing project a little bit so that it uses that managed object context to fetch the data, save the data, and all of that stuff. All right, so in this lesson, you learned how to set up your Xcode project to use core data. In the next lesson, you'll learn how to create, retrieve, update, and delete data from core data. So I'll see you there. Hey Code Crew, in this lesson we're going to continue our core data series, and I'll show you how to create, retrieve, update, and delete data from core data. Alright, now let's jump into Xcode. Alright, so in this Xcode project I'm going to show you how to create, retrieve, update, and delete data from core data. Now I did set up a lot of the UI for this project, and I'm only going to be focusing on the core data transactions bit. And the reason for that is because if I showed you how to build the UI, 90% of this lesson would have just been building UI, with 10% being the actual core data bits, which is the focus of this lesson. So that's why I built it out, but I'm going to walk you through the UI work that I've done so far, and I'm going to show you where the missing core data bits are that we're going to fill out together. Okay, so first of all, what data are we working with here? So back in lesson 2 and lesson 1, we were talking about a person entity. Same thing here, person entity. These attributes are the same, which I've defined. I've generated the, actually before that, I've set the code gen to manual and none. That means I have to manually generate the subclasses. And you can see that I have done that here. So here's my class, there's nothing in here, and these are the properties mapped to the attributes. Okay, so what does the UI look like? If I go to the main.storyboard, you'll see that I have a table view, which I'm going to use to display all of the people in our database. And then we have an add button up here, which I'm going to show an alert or a pop-up with a text box where we can type in a name, and that's going to add a new entry into our core data database. We're going to be able to swipe each row to delete that person from the database. And finally, we're going to be able to tap on a row and pop up that alert again and be able to edit the name and then save it. So that's updating data. Now I do want to mention that in this lesson, I'm not going to explain how table views work and how a lot of this UI is constructed, because we've gone through a lot of this stuff in previous lessons. If you haven't seen those, or you're still confused about table views and protocols and delegates and stuff like that, and how the table view gets data from the view controller, do visit my other lessons, especially the 29-day beginner challenge, which I'll link to. I'll put a card up on the screen. So let's dive into the view controller, and let me show you some of the code. We're going to do retrieval first. I'm going to show you how the table view gets the data, and then we're going to hook that up to core data. So this items property right here, this is the array of data that is powering the table view. As you can see now, it's not set to anything, but that's where we come in, and we're going to hook it up to our core data. So we're going to start at the top by getting a reference to the managed object context. Remember from the previous lessons, I explained that you don't work with the core data persistent store directly. There is a layer called the managed object context that you interact through to save and retrieve your data. So how do we get a reference to this managed object context? Well, inside the app delegate here, you see this property for a persistence container. So we're going to get a reference to this, which is going to give us the core data persistent container. And there's a property on this object, which gives us the managed object context. So up here, we're going to say UI application.shared.delegate, and we're going to cast that as an instance of the app delegate. And then we can access that property I just showed you called persistent container, and then a property off of that called the view context. This is the one we're looking for, the NS managed object context. So we're going to keep a reference to that, and we're going to call it context up there. And that's going to make it easy for us to basically use the context to retrieve and save. We're going to be using this reference a lot. Okay, so down here in the view.load, this is standard hooking up table view stuff. There is this method here called fetchPeople, and that's this method right here. As you can see, it doesn't do anything right now, but we are going to fetch the data from core data to display in the table view. All right, so the way we do this is context.fetch. And you can see here that, first of all, it throws an error. If it cannot fetch what you're asking it to fetch, then it's going to raise an error. So we do have to wrap this in a do catch block and handle that error. But you'll notice that the other thing it accepts is a fetch request. Now, we're going to start by putting in a very simple fetch request to say retrieve all of the people objects. But in the next lesson, we're going to take a look at other types of requests that you can do to sort and filter. All right, so let's choose one of these, and let's choose this one right here. I don't think it really matters right now. And I pointed this out to you in lesson 1 or 2, but you can see here that it's got a a static or type method here called FetchRequest, and this actually returns a fetch request for all of the person entities in core data. So this is the method that we're going to call of the person class to generate a fetch request that we're going to pass into the managed view context. So let's take a look at how that works. So since it's a type method, I don't have to declare a new instance of person. I just go person.fetchRequest like that. All right, so I'm passing in a request to grab all of the person objects in core data. And we can either, do the try keyword like that to not care if any errors get raised, or we can actually handle the error properly. So, we're going to do a do catch block like this. And again, I'm not going to explain or cover this in depth right here, since this lesson is sort of a little more advanced. So essentially, we are trying to fetch this. So we are going to assign the results. It's going to be an array of person objects. We're going to assign it to this property up here. So self.items equals, and we're going to try. So after all of the items get fetched, then we assign it to this array. We got to tell the table view to refresh or reload its data. So that's what we're going to do here. Table view dot reload data. Now I'm going to do this in the main queue, because sometimes we're going to be calling this fetch people method from a background thread. So the way we do that is we use dispatch queue.main.async, and this is going to because this is UI work. When you reload the table view, it's essentially going to fire all of those methods to grab the cells and stuff like that, and that's UI work. So we want to make sure that we're doing that in the main thread. And just in case you're not sure about why, it's really the main thread that should be updating and handling the UI. When you start trying to do that from the background, then a background process or thread, then you might start getting performance impact or hits. Okay, so just from doing that, we should be able to see something, because I do have a single person object inside core data right now. So if I run the project, you're going to see that it indeed goes to fetch data, and we have one entry, and it's just placeholder right now. Yeah, just ignore that for a second. The reason why it says placeholder is because for this self or row at method, I just set the text of the label for that row to placeholder. But we're going to, I guess we could change that right now. So we're going to get the person from the array, let person equals self.items, and we're going to pass in index path.row, and that's going to give us the person. And then in here, we're going to say person dot name. This is an optional, so I'm just going to force and wrap it, and we'll grab the name. So let's run it again. And instead of placeholder text, we actually see the name of the person object. All right, so now that's fetching data from core data. It's as easy as that, except that right now you can only fetch all of it. You don't know how to sort of sort and filter, but we're going to cover that in the future. All right, now for adding data. How do we add data? Right now, when we click this button, I'm just popping up a pop-up to ask for the name of the person, and we're going to create that new person object and add it to core data. All right, so that's this button handler right here, add tapped. So all I'm doing here is creating a new pop-up. You can see here, I'm adding a text field, and then I am writing a submit button that says add, right? And when that add button gets tapped on, so if we go back here, they'll fill in a name like Joe. When this add button gets tapped on, this is the code that's going to get run. All right, so how do we access the text in this field? Well, the alert, since we added a text field to the alert through this add text field method, we can access the array of text fields like this, alert.textfields. And we can access the first one, because there only is one. We only did this once, right? So that's our text field right here. And here we're going to create a new person object, and then we're going to assign the name and the age and the gender and stuff like that. All right, so let new person equals, and we're going to try to create a new person object like usual by using these rounded brackets. But you'll see here that because this is a subclass of NSManagedObject, right? That's what allows it to be saved into core data, like we had talked about. Because that's the case, you'll see that I have this option right here, right, to create this person object in a specific context, right, in a 𝗟𝗶𝗺𝗻 NSManagedObject context. Well, we're going to pass in the context that self.context. We're going to pass in this context up here, right? That's how we're interacting with our core data persistent container. Right, so where was that code? Right here. So just like that, we've created a new person object in that context, and now we're going to set some properties for it. So new person dot name is equal to text field dot text, and this is that text field right there in the pop-up. And for the age, I'm just going to set it to some arbitrary number. Same thing with gender, but I assume that you would ask for all of this data, you know, when you're adding a new person. Okay, so just creating a person object in the context is not enough to save the data. You actually have to save it. If you don't save it, then the next time you run it, you won't actually find this person anymore. It doesn't get saved into core data. So the way you save the data is through the managed object context. So self.context.save, and that's simply it. Notice that this method also throws, right? So you can wrap it in a do catch block and, you know, try to catch an error if there's a problem saving it. So you have to put a try keyword in front of the throw method. You can do this and try to catch the error if there's a save data error, or you can simply not care if there are errors or not and do that. If this were an actual app, I would definitely try to catch all the errors and respond to it and let the user know that there was an error in saving the data and all of that. All right, so saving the data, and then we have to refresh the table view because all we've done now is create a new person object and we've saved it to core data. But that doesn't change this array which the table view is reading off of, right? So I am going to call the 𝗟𝗶𝗺𝗺 method right here, self.fetchPeople. And just in case you don't remember about this 𝗟𝗶𝗺𝗺 method, if I scroll up here, all it does is it hits the managed object context, passing in a person fetch request to grab all of the people objects back, assigns it to this property which the table view is reading off of, and then calls tableview.reload to reload the data. And good thing that this puts it on the main thread because we're calling it from a background thread right here. And this is a button handler from the submit button. Okay, the last thing to do is add the button to the alert and then to present the alert. So let's run this code, and we should be able to add new objects to our database. So let's say Joe. When I hit add, what's going to happen? It's going to create a new person object in our managed object context. It's going to save the context, thereby saving the object into core data, and then it's going to call fetch to fetch that data back from core data, or fetch Joe back from core data. So add, boom, we got Joe. Nice. All right, so now let's do delete. So I did this. It's just a swipe action on the table view row. It's actually very easy to do. Down, where was it? Right here, trailing swipe action. So that's what we're configuring. So we're going to create a new swipe action. All it is a UI contextual action, and the style is destructive since it's going to be a delete function. The title is delete, and then here is the handler, the code for what happens when you trigger that swipe action. So first, let's get a reference to the person object that we want to remove. So let person to remove equal self.items, all right, and as a parameter, it tells you which row was swiped on here. So index path.row. Okay, that's going to give us the person to remove. This is optional, so let's unwrap that. Okay, so now actually to remove the person. And again, we do these core data functions through the managed object context. So self.context actually delete object, and you just pass in the object. So here we're going to pass in person to remove. And again, you have to save or else it's not going to take effect. So view.context.save. Again, it throws, so you're going to wrap this in a do catch and catch that error if there was an error in deleting, in the deletion. Save the data and then refetch the data here. Self.fetchPeople. All right, so let's run this and test that out. So let's delete Joe. Delete. So he's gone. And if I rerun my app, you'll see that we only have Ted. Okay, so we can add another person, Sammy, to replace Joe. Okay, so now the last thing is did select row. When we, let's say, select Sammy, all I'm doing here is throwing up a pop-up, same idea with the text field. Let's take a look at the code. We have here did select row. Here I'm just getting the person that was selected through this parameter that indicates which row was tapped on. And then I'm creating an alert. I'm adding a text field, and I am getting a reference to that text field from here. And I'm preloading the person's name, all right, the selected person, preloading his or her name into the text field so that when it brings up the text field, we have the existing name in there already. And then I configured a save button. So you can see here the handler, when that gets tapped, that is where we are going to edit the name. So the selected person, we got a reference to it up there already. Dot name is equal to whatever name is in the text field now, assuming that person did actually change the name. And then again, save the data. And then finally refetch the data. So let's run this code right now. Oh, and the last thing I did was add the save button to the alert and then present the alert when upon tapping of a row. Okay, so let's tap on Sammy and let's save Sammy as Joe. So now when I relaunch the app, you can see that it's Ted and Joe. So just to do a quick recap on all four of the operations we talked about, in terms of fetching, you call the fetch method of the managed object context and you pass in a fetch request. Now that could be a fetch request for all of the objects of that type, or it could be one that's sorted and filtered upon, which you'll learn in a future video. In terms of inserting people or adding new data, what you do is you create a new object in the context, right? And then you call save. And then for deleting, you call the delete method of the context and you pass in the object you want to delete from core data, and then you have to remember to save it. And finally, for updating, you simply change whatever you want to change on that object, and then you save it.
All right, so now you learned how to create, retrieve, update, and delete data in core data. In the next lesson, you'll learn how to sort and filter the results that you get back from core data. All right, I'll see you there. Hey Code Crew, in the last lesson you learned how to create, retrieve, update, and delete data from your core data database. In this lesson, we're going to learn how to filter and sort our data so that you can retrieve only the results that you want from your core data database.
Now, filtering allows you to only return the results that match a specified criteria, while sorting allows you to return your results in ascending or descending order based on an attribute that you specify. All right, let's jump into Xcode. So here we have the Xcode project that we worked on in the last lesson. And just as a reminder, in this 𝗓𝗶𝗺𝗺 method, we were retrieving all of the person objects from our core data store through the managed object context. If you remember, we don't interact with the core data persistent store directly, right? We create, retrieve, update, and delete data through the managed object context. So that's what this variable refers to, context.fetch, and that fetch method is how we retrieve data from the core data store. Now, you have to pass in a fetch request into that fetch method. And this fetch request actually indicates what you want to retrieve, how it's sorted, what sort of criteria you have for retrieving the data. In this particular case, we wanted to fetch all person objects. And so we just passed in a fetch request as is. Now, where did this fetch request come from? If you take a look, we're calling a class method called fetchRequest on the person class. So let's go into that and take a look at what it is. Let's go into this person class here. As you can see here, this is the fetchRequest class method. And what is returned from this method is a new NSFetchRequest object. And the data type of the data returned is set to be person, right? And that is what gets returned, right? And so it's essentially going to fetch all person objects. In order to filter and sort, we actually have to set some properties on this fetch request before we pass it into this fetch method. So why don't we, instead of putting in the fetch request here, let's declare a variable or constant up here and move this line of code. Just have the fetch request up here, right? And then we're going to set the filtering and sorting on the request, and then we're going to pass the request into the fetch method. Now, you're going to get an Xcode error, as you can see here, ambiguous use of fetch request. So you actually have to indicate the type, that this is an NSFetchRequest, and the data type that it's going to return is person. So now that we have a reference to the request up here, let's take a look at how we can do filtering first. I'm going to run the project so that we can see what data we're working with, and so we can decide what data we want to filter for. So as you can see, we have 4 names here. I am going to just do a simple filtering for only person objects with the name Ted. All right, so let's go ahead and stop the project. Now, to filter based on some criteria, we use this class called NSPredicate, which lets you define different sorts of conditions in a very easy to understand sort of text manner. You'll see right here. So I'm just going to call it pred equals NSPredicate, and we can use this one, or we can define a format and pass in the arguments. So because we want to define criteria based on the name property of the person class, let's take a look here. So you see it's got a name property, and that's where you saw the Ted, the Joe, the Abby, the Mike. So I'm going to specify this string where I'm going to say the name property contains Ted, like that. And you have to put this criteria here in single quotes. And then we have to add this predicate to a property on the request. So the fetch request actually has a property called predicate, where you can pass in the criteria that we just defined. And just like that, if I run it now, it's going to only return person objects where the name contains Ted. And I will show you a couple of different examples of sort of what you can filter on in a second, and how you can combine different things and use different operators here. So let's run the project to quickly see what we have. So as you can see here, it's only got the person Ted now. Now, you saw earlier how I was configuring this format, and there was a second parameter
because typically the thing that you want to filter on may be dynamic, right? This, you might not know this beforehand, so you can't actually code it in like I have now. So in that case, what you do is you put in a sort of wildcard character, and that is defined by %@. And then you can do comma here, and then you can specify whatever variable contains the thing that you want to filter on. Now, I don't actually have a variable to indicate what I want to filter on, so here I can just put an example as a string. But if you had something that you wanted to filter on, you can specify a wildcard in your criteria and then indicate that dynamic variable here. Now let's take a quick look at some other ways you can define your criteria using NSPredicate. So here I have the Apple documentation for the NSPredicate class. There are some common examples I'll go through with you in the overview, but there's also a detailed guide that you can go through called the Predicate Programming Guide. I'll provide all these links below the video. This guide, if you want to really dive deep into how you can express your queries using NSPredicate, then definitely take a look. Now, some of the more common examples are contains, which is the keyword we just used. There's also equality with double equal signs, and you can use like. Here's contains. You can ignore case and diacritics, which are the accents on top of letters. If you want to ignore both of them, you just put a angle bracket and square brackets, and you put CD to ignore both, or just C or just D to ignore these respective things. You can also combine different conditions together, just like an if statement using or and there are different keywords to express time, and you can use math inequalities like less than or greater than, and so on and so forth. So definitely give these things a look if you are trying to express some sort of query and you're not finding the right way to write it. I'm sure a quick browse through this Predicate Programming Guide will give you some insight on how to express that query. Again, links to these documents below the video. All right, now let's take a look at sorting. Now, similar to how the NSPredicate class is used to define your criteria for how to filter, the NSSortDescriptor class is used to indicate how your results should be sorted. Let's go ahead and create an NSSortDescriptor and indicate that the names should be sorted in alphabetical order. Now let's take a look before we do that. Let's just comment out this predicate, and I'm gonna run the project again so that we can see how it's sorted naturally first. So you can see here it's Joe, Ted, Mike, and Abby, and it's not in alphabetical. So I'm going to want to sort it in ascending order. So let's go ahead and create a new sort descriptor, NSSortDescriptor. And as you can see here, again, you sort by a particular attribute, or in this case, they call it the key. And we're going to specify ascending is true or false. So I'm going to sort by name, and I'm going to say ascending is true. And now, just like with the predicate, we have to set it to the request. So request has a property called sort descriptors. And if you take a look at the type, it's actually an array of sort descriptors. The reason for this is so that you can specify multiple levels of sorting. For example, a list of names is usually sorted by last name. But however, if two people have the same last name, then their first name is used to determine who comes first. So in this case, since we only have one sort descriptor, we still have to pass in an array. However, it can be an array of just our single sort descriptor like that. All right, now I'm going to run the project, and you'll see that it's going to be sorted by name in ascending order. As you can see, it's Abby, Joe, Mike, and Ted. Now, before we end this lesson, I want to point out a few more useful properties of the NSFetchRequest class that you can use to customize your fetch. For example, you can limit the number of objects that you return using fetch limit. You can also start the result set from a certain offset, such as this property right here, and you can choose to only return specific properties of the objects and much more. So I'll link to this article or documentation below the video.
Alright, so in this lesson you learned that you can customize certain properties of the fetch request before passing it into the fetch method of the managed object context. Specifically, you can specify a predicate using the NSPredicate class, and you can specify sort descriptors using the NSSortDescriptor class. Alright, I hope that was helpful in specifying how your objects get returned from core data. In the next lesson, I'll show you how to specify relationships between your different entities in your data model. Hey Code Crew, in the last lesson you learned how to filter and sort your data using the predicate and sort descriptors properties of the fetch request. In this lesson, you'll learn how to specify relationships between your core data entities. Alright, let's get started. If you remember in lesson 1 of this core data series, I showed you a diagram that illustrated what an object graph is. We had the person objects and a family object, and the family object held an array of person objects. We're going to recreate this relationship in our data model. Let's go into Xcode. So here's the data model for our core data entities. And the first thing we're going to do is to add a family entity. So go ahead, click Add Entity, and let's change this entity name to family. The other thing we're going to do is let's just add an attribute called name and change it to string. And finally, here's the part where we define the relationships between our different entities. So we're looking at the family entity right now. We're going to hit plus under relationship, and we're going to name this relationship. And what ends up happening is it's going to be a property, just like these attributes are. So I'm going to call this people, and it's going to essentially store all of the person objects that's part of this family. So the destination is basically the data type. I'm going to choose person, and inverse here, there's nothing to select for now, but we're going to talk about that in just a second. So first of all, let's go over to the attributes section of this relationship and specify the type and change it from to one to many. And that means that this people property can store multiple person objects. Essentially, it's going to be an array of person objects. Now let's go over to the person, and we're also going to specify a relationship here, but in the inverse. So it's going to define that a person belongs to a family. So under relationship, hit plus again, and for this property, I'm going to call it family, and the destination is essentially the type of this property. It's going to be family. And for the inverse, if you pull this down now, you're going to see that there is an inverse, and this is that relationship that we defined here, right, in the family entity. So that's what we're going to want to select. And then if you go back to the family entity, under this relationship, you're going to see that this inverse has automatically been set for you, right? And you can specify that the inverse of this relationship is the family property of the person object. And the reason we specify this inverse is so that core data can maintain the data integrity of our object graph. Even if you're not going to use the inverse, for example, you want a family object to hold multiple references to different person objects, but you don't really care that a person object has a reference back to the family object, you should still specify this inverse relationship in your data model. Again, this is something that Apple recommends that we always specify this inverse relationship so that it lets core data maintain the integrity of the data. All right, now that we've specified this simple relationship between our family and person entities, let's go ahead and regenerate our classes. Actually, I forgot. For this family entity, I'm going to set it to manual code generation as well, just like I have for the person. And since it's set to manual, that means we have to regenerate these classes every time we make a change. Now, first of all, I'm going to go ahead and delete my existing person class because, as you can see, it doesn't account for that relationship that I just added. So let's go ahead, select both of these and choose delete and move it to trash. Now I'm going to choose editor, and I'm going to choose create NS managed object subclass, select the data model, make sure that my entities are selected, the ones that I want to generate the classes for,
hit next, and let's just save it right there. Now I'm going to drag all of these into my model group. So one of the first things I like to do after generating these classes is press Command B just to make sure that everything builds successfully. And if you get a failure, sometimes it's just because Xcode's detecting some artifacts that should be gone in the build folder. So what you do is go to Product and hit Clean Build Folder. And that will usually do the trick, and you can press Command B and build it. Again, just to make sure that everything is fine. And also sometimes Xcode won't detect your new classes and you'll get some weird autocomplete errors, and you'll see some Xcode errors even though you can run the app successfully. If that happens to you, usually quitting Xcode and restarting it will do the trick, and that's what happened to me the first time I was working with this. So I just thought I'd mention it. Now what I'd like to do is just to review the classes that were generated and point out some of the differences to you based on what we edited in the data model. So taking a look at this person class now, we have a family property. You can see that the data type is family. So this is a reference from the person to the family. The inverse, if we go to the family class, you can see that here's the name attribute that we specified, and here's also the people relationship that we specified. The data type is actually an NS set. It contains a set of people. But take a look at this. Down here, there are a couple of methods. So there's two methods. It's called the same thing, add to people, but this is allowed because the signature is different. All right, the parameter that you pass in is different. One is for adding a single person object to that set here. And this one is if you want to add, multiple person objects to this set. Same thing goes for remove. Remove a single person or remove a set of people. Now, I think you can guess that it's pretty straightforward to specify this relationship. And that's why I didn't really modify the user interface of our existing demo app to accommodate families and to specify relationships between people and families, because the work that it would have taken me just to create all of that new user interface, it's much faster for me just to demonstrate to you and show you the code for you to create a couple of these entities, specify the relationships, and save it to our core database. So let's go ahead and do that. I'm going to go into our view controller, and maybe I will, I'll just do it in a random method here, because I don't want to confuse you by writing it in some other method. So I'm just going to say relationship demo, and just create this new function here, or new method here for us to write this code. So let's create a family, create a person, and then lastly we have to remember to save the context. Okay, so let family equals, so we're going to create a new family object in our managed object context. And so that's the context we want to create it in. And why don't we go ahead, let's set that to var actually, because I want to change the name. Let's call this the ABC family, and let's create a new person in this context as well. And oops, let's set the person's name to Maggie. Okay, so how do we specify a relationship between the family and the person? Well, there are actually two ways you can do it, because we actually have relationships or properties pointing both ways. So very simply, you can set the family property of the person to this family up here. And just like that, you've specified that relationship. After you do that, when you try to access family.people, you'll find that Maggie is actually in that set, right? And you're gonna have to save it, so context.save. So that's the first way you can specify the relationship, and as you can see, super easy. The second way you can do it is by using those methods that I showed you. See? Add to people, and obviously you probably have to do this down here. You pass in the person. Oh, and actually, we can use let for this. And so that's the second way. Using any of these two ways to specify relationships between your objects and building your object graph like that, after you save it to core data and you bring it back, those relationships will get maintained, right? So if you bring back this family, you'll be able to look through the people and find Maggie. And likewise, if you only bring back Maggie from a core data fetch, you're going to be able to access this family object through the person.family property, like that.
All right, so that's the end of the core data series for now. You know just enough to start applying this knowledge and using core data in an app. Now, having this core data knowledge is already going to open up a lot of app possibilities and ideas that we can build together on this channel. If you don't want to miss it, please make sure you're subscribed to the channel by hitting that red subscribe button below. And lastly, if you enjoyed this series and you learned something new, please give this video a thumbs up. It really helps with the YouTube algorithm and getting exposure for this series. Finally, I'll leave you with this. What kind of app are you going to build with these newly found core data skills? Let me know by leaving a quick comment below. All right, I'll see you in the next lesson.